Good morning. I'm Dana Revis. I'm the training coordinator for the Office of Environmental Health Services at the Virginia Department of Health.
And my name is Lance Gregory, and I am a environmental health coordinator with the Virginia Department of Health.
Today we're going to talk about geothermal wells and permitting in well construction in Virginia. In Virginia, we have 5 physiographic provinces: the Appalachian Plateau, the Valley and Ridge, the Blue Ridge Province, the Piedmont, and the Coastal Plain Province. And our well regulations cover all 5 provinces, but well construction is a little bit different in each of the provinces. Well construction is mainly governed by the rock type. So in the Appalachian Plateau and the Valley and Ridge Province, we have primarily sedimentary rocks, whereas in the Blue Ridge Province, we have igneous rocks, and we have metamorphic rocks in the Piedmont Province. In the coastal plain, we have unconsolidated sediments, which are a little bit different than sedimentary rocks, and all of these affect the way that wells are constructed. In the Valley and Ridge Province, we have highly folded and fractured rocks, which present special challenges in well construction. And it results in a really complex geology, so it makes it kind of hard to figure out some of the environmental hazards when you construct wells. This shows a bit about well construction in carbonaceous rocks or limestone rocks versus regular metamorphic or igneous rock types, and includes sedimentary rock types too. The consolidated sediments we have in the Valley and Ridge and the Appalachian Plateau. In the limestone rocks, you can see that we have solution cavities or solution openings, and this allows. These are it's hard to predict where the water is moving in those types of rocks. Whereas in normal non-carbonaceous rocks, I guess it's not really normal rocks, but in non-carbonaceous rocks, we tend to have fractures that are in sets that have a common orientation, and it's a little bit more predictable how water moves in those types of rocks. So these present special challenges to well construction. In general, in the Coastal Plain Province, one of the things that we've figured out in the last 20 years is that the geology in the coastal plain of Virginia is governed by an impact structure from a meteorite, basically, that occurred many, many years ago, and this has caused a disruption in many of the aquifers that we have in the coastal plain province. Some of the things that we didn't understand about groundwater in the coastal plain are explained by this impact structure. It doesn't have a lot of impact though on how we construct geothermal wells. So in Virginia, our private wells are governed by the Virginia Private Well Act, which is a part of the Code of Virginia. And geothermal wells fit into the category of private wells in Virginia. The General Assembly has set out the Code of Virginia that covers the construction of private wells and has handed that off to the Board of Health, who has written regulations that cover the construction of private wells. And these are the Virginia Private Well Regulations. The regulations start off with a list of definitions, and basically a private well is any well that's constructed for a person on land which is owned or leased by that person and is usually intended for household, groundwater source heat pump, agricultural use, industrial use, or other non-public water well. So these are for private homes or for agricultural, industrial, or ground source heat pump wells. That's the definition of private wells. A closed-loop ground source heat pump well in our regulations is defined as a well consisting of a sealed loop of plastic pipe buried beneath the Earth's surface to allow heat transfer between the fluid in the pipe and the Earth. And then emergency well replacements also apply to ground source heat pump wells should a well fail to deliver the water that is needed for its intended use. The emergency well replacement gives us a means to issue a permit to replace that well a little bit simpler than when we issue a permit to construct a new well. The main problem when constructing a well is to prevent contamination of the groundwater by surface water. So normally when we construct a well, the well driller drills the borehole into the earth, and then they insert casing to hold that borehole open. So the trick in constructing a good or a well-constructed private well is to seal that annular space between the borehole, the outside of the borehole, and the casing properly to prevent infiltration of surface water into the groundwater. So our regulations specify how that grouting is done and what type of grout materials are used to grout between the borehole and the casing. We have, I guess there are 4 classes of wells altogether. There's a 3A and B well, which requires, a 3B well requires 50 feet of casing and grout. And then we have a 3A well, which is cased the entire depth of the well and grouted 20 feet, cased 100 feet with screen in the bottom of the well, and then grouted 20 feet. And then there's a 3C well, which can be bored in rock, and then requires 20 feet of casing and grout. And so these well classes can apply to geothermal wells, such that the well is drilled, the casing is inserted, and then the casing is grouted the depth that is specified by the class of well, either 50 feet or 20 feet as shown in this picture. So you have the green lines represent the ground source heat pump loop, and then the rest of the well is constructed as normal drinking water wells are constructed. Our regulations also specify that a ground source heat pump well can be constructed without casing, and in that case, the entire loop can be grouted, which allows the well driller to place it without worrying about the separation distance to sources of contamination. So we'll talk about a little bit about well placement and location in our regulations, and a little bit about construction. Those are the general concepts, and now we'll show the specifics of our regulations. So a geothermal heat pump well is considered to be a Class 4 well. It's a non-drinking water supply well in our regulations. And when we construct Class 4 wells, when we construct Class 3 wells, which are our drinking water wells, our main concern is to create a well that provides potable water. And so we're protecting the water source. In the case of Class 4 wells, the regulations state that the intent of our regulations is to protect groundwater quality in general and not to ensure a potable water supply, since it's not water that's used for drinking. It's kind of a subtle distinction, but it's an important one in some cases where we might construct ground source heat pump wells as opposed to drinking water wells. So this particular section of the regulations states that closed-loop ground source heat pump wells do not have to be cased. When wells do have to be cased, we have to extend the casing above ground 12 inches or 12 inches above a concrete floor in a well house that has a gravity flow drain. And with ground source heat pump wells, they're normally constructed in a field of wells where you have like a grid of, it could be a dozen wells, it could be more than that. So you can see we're having 12-inch casing above grade for each of those wells would be kind of disruptive to the landscape. So this regulation states that closed-loop ground source heat pump wells do not have to have 12 inches casing above ground. So that's an important detail. This section of the regulations talks about grouting and about how all private wells shall be grouted, and explains that the annular space between the casing and the well bore is one of the principal avenues of undesirable water and contaminants that can gain access to the well. So therefore, the regulations specify how wells are grouted and the types of materials that can be used as a grouting material. And so this is a lot of words here, but it talks about well location and gives us the separation distances from potential sources of contamination based on the standard to which the well is constructed. So Class 3C, which are the wells that are grouted to 20 feet, and Class 4 wells form one category as far as separation distances go, and then Class 3A or 3B wells form another category. So the 3C wells are cased and grouted to 20 feet, and we require a 100-foot separation distance, basically, to sources of contamination. Whereas a Class 3A or B well, which is the Class 3A well, is cased minimum 100 feet and grouted minimum 20 feet, and a Class 3B well is cased and grouted to 50 feet. And that basic separation distance for a Class 3A or B well is 50 feet. So basically, you can get closer to a potential source of contamination with a well that has more casing and grout. That's the general principle in our regulations. And if a geothermal well is constructed to either of these standards, then these are the separation distances that apply to geothermal wells as well. Also, we also take into consideration if a well is sited downslope from a source of contamination, because contamination moves downhill by gravity, just like it does anywhere else. So that includes termite-treated foundations, it includes underground storage tanks, and other potential sources of contamination. We also don't want to site wells in swampy areas, low areas, or areas subject to flooding when they're drinking water wells. That's one of the reasons that we make a distinction between drinking water wells and non-drinking water wells. And then we also have separation distances just for practical reasons from property lines and utility lines and those types of considerations. For ground source heat pump wells, when a ground source heat pump well, a closed loop ground source heat pump well is constructed, if the well is constructed without casing and is grouted the entire depth, then that well doesn't have to comply with any of the separation distances that we were just talking about. So that's one of the reasons it's important to understand the difference between, I guess, conventional well construction techniques and constructing ground source heat pump wells. So if the well is, you'll see in this regulation, if the well is grouted to a minimum of 50 feet, then the separation distances for Class A, 3A, or 3B wells have to be honored. If the well is cased and grounded to 20 feet or Class 3C or Class 4 standards, then it has to comply with those standards. But if we don't put any casing in the well, we just put in the closed loop and we grout the entire depth of the well, then the well doesn't have to comply with those separation distances listed in Table 3.1 that I showed earlier. And then I mentioned that we do have a procedure for permitting a heat pump well when, in an emergency situation, if the heat pump well were to fail, then we have a special permitting process to permit a replacement for that. When any well is constructed in Virginia, including ground source heat pump wells, we need to have a uniform water well completion report, or a GW2 is another form that well drillers use to report on the basic construction information of the well. It has two sides, so it allows the driller to give us a diagram of how the well is constructed as well.
So in 2009, we had several legislative acts, and one of those was Senate Bill 1128, which dealt with geothermal wells, and it established an express geothermal well permit for closed-loop geothermal wells, geothermal heating systems, and also created a single application fee for closed-loop geothermal heating systems, regardless of the number of wells. The reason why that's important is because prior to 2009 and subsequent issuance of GMPs and changes to the regulations, VDH previously charged an application fee for each group of 10 wells, but now after this legislation, we only charge a fee for the system as a whole. So whether you have 2 wells in the geothermal system or 300, as long as it's all part of one system, there's one fee for that. As the previous slide showed, we did have amendments to the regulations that were put into effect in August 16th of 2012. The goal of geothermal well amendments were to streamline the permitting process for these wells and also allow VDH the opportunity to inspect and do necessary oversight of these construction sites, but then also reducing those fees. Again, if previously if you had 300 wells, that would have been 30 applications, whereas now it's just one. As far as the fee, there's a fee of $300 for our applications. In 2009, VDH issued GMP 60A, which put into place those requirements to collect only a single application fee. And then once those amendments to the regulations went into effect in 2012, that was also captured there. As far as the express geothermal well permits, that's contingent upon the local health department receiving a proper registration statement and payment of the application fees. You would just submit a single application fee along with a single registration statement for the entire geothermal system to the local health department. That registration statement needs to include a site plan that's drawn to scale that shows the proposed well sites, shows the property boundaries and recorded easements, an accurate location of any potential sources of contamination that might be within 100 feet of the proposed wells and other applicable site features. So once the local health department has acknowledged that you paid the appropriate fees and collected the registration statement, they will countersign the registration statement, and then construction can begin. The local health department will then conduct inspections of the geothermal wells at various stages throughout the construction process, and well drillers are asked to contact the local health department prior to beginning construction so that they can schedule those inspections. As Dana mentioned earlier, any well that's constructed is required to, the driller is required to submit a uniform well water completion report. And once that's been submitted to the local health department for a geothermal well and an inspection has been conducted, the local health department will then provide the owner with a statement that the wells are approved for use. To go in a bit more detail with the registration statements and geothermal well, express geothermal well permitting, the registration statement is going to act as both your application and also act as the permit once it's been countersigned by the local health department. The local health department is going to exercise their due diligence to review it immediately, and that's as quickly as possible, so that you can get that counter signature and begin construction. Again, well drillers are asked to work with the local health department, let them know when they're going to be submitting registration statements for express geothermal well permits, so that we can have staff available to review the registration statement and any site plan that's provided, and get that sign on, that counter signature, as soon as possible. Again, the local health department staff are going to review that registration statement for completeness, and they're also going to review any files that we have for that property at the local health department. Again, as Dana was mentioning, keeping in mind that Section 380G, which provides the exemption for closed loop ground source heat pump wells, in that if the well is grouted the entire depth of the well, then the well doesn't have to comply with the minimum separation distances contained in the private well regs. Just a couple of questions that we've received regarding those changes to the regs in 2012. One of those is, do the express geothermal well permitting processes parallel express class 4 well permitting processes? So we have two different express well processes outlined in the regulations. The difference between the geothermal well and the class 4 could go not only for geothermal wells, but also agricultural wells, industrial wells, all non-potable uses. Some of the differences there: the geothermal well is going to be an immediate process, whereas the class 4 wells, we're kind of doing those as soon as we can. But there is a potential quicker turnaround on geothermal well permitting process. The express geothermal well permits are good for 54 months, whereas the express class 4 well permits are only good for 30 days. And then the express geothermal well permitting process can be done on any property, whereas the class 4 well express permitting process only applies to properties that do not have an on-site sewage system, whether active or inactive. So another question is, can people still use the class 4 express well process for geothermal wells? And the answer to that is yes. So you have an option with geothermal wells as to which process you want to use. However, again, if you use the class 4 well express permitting process, then the site cannot have either an active or inactive on-site sewage disposal system. And again, there's differences in how long that permit is good for. And so just to give some idea of the scope of how these regulations and these processes have been captured and been done in Virginia to this point, we do collect data on private well permits. And you can see here the numbers of geothermal well systems installed in Virginia that we've collected data for, and it's increased significantly from 2007 to 2013. I imagine the data for 2014 is probably low because we've probably permitted a number but haven't received maybe the uniform well water completion reports to say that those systems have been installed. And then again, where you see 2012, 213 systems installed, that could be more than one well for each of those systems. That could be any number of wells. Again, some of the smaller residential systems may only have 2 or 3 wells, whereas some of the larger systems may have several hundred wells involved. This is just to give an idea of how those numbers have increased over time for us and the scope of this issue in Virginia.
So these are some of the sources that we referred to. Our website is at vdh.virginia.gov, and we also, you can find the Code of Virginia at lis.virginia.gov. The Town Hall website has information about new policies and regulations, and then the geology information came from the William and Mary geology website. And that's all we have. Thanks.